Welcome back to All This Math. This is Professor Parker, and today we're going to get into some statistics. And I'm going to try to break this problem down. It is a little lengthy, but I'm going to try to break it down because I know a lot of people get real nervous when just the word statistics is even mentioned. But I don't want you to be nervous when you hear the word statistics, because one of the things I want you to understand is this. We have to differentiate between difficulty and tediousness, or tedium. I'm not sure what the proper term is. What I mean by that is this. Statistics is often not difficult, but it's very tedious. And I think that a lot of times when we're dealing with math, when we deal with problems that require a lot of steps, we automatically think, oh, this is too hard. It's not that it's too hard, it's just that it's a lot of steps. It's a lot of easy steps repeated over and over again. So that's what makes you think that it's difficult, but it's not actually difficult. It's just a lot, right? So don't psych yourself out. I think that's important because a lot of people psych themselves out by saying to themselves this negative self-talk, saying, oh, this is too hard. It's not too hard. It's tedious. I mean, it's kind of like washing dishes after Thanksgiving dinner. It's a lot of dishes and a lot of pots and pans. But washing dishes is not difficult. You know how to wash dishes. It's just tedious and annoying because you got to do a lot of it. You got to keep using more dish detergent. You got to keep using more water. You know, your hand might start cramping up from all the scrubbing and everything, but that's not difficult. You can do it. It doesn't require a lot of thought. It's just tedious because it requires you do it over and over again. So I want you to think about that when we do a lot of statistics problems. It can be very tedious. All right. But then here's another thing. Once you start doing a lot of these, then your muscle memory kicks in, and then you start to just kind of run through problems. So then it's not really that bad. All right. Anyway, we're dealing with a frequency distribution table, right? And we're going to fill in some information, and then we're going to find the mean, the median, and the mode. All right. But before we do that, I definitely want to say rest in peace to this brother that is on my t-shirt. If you are not familiar with him, this is the chairman, Fred Hampton, who was the leader of the Chicago branch of the Black Panther Party for Self-Defense in the late 1960s before he was assassinated by the Chicago Police Department on, I believe, December the 5th, 1969 or December 4th, 1969. I need to check on that. It was in that time period, though. A young brother, like 21 years old. This is one of his quotes that is on the t-shirt. If you can see it, it says, you can kill a revolutionary, but you can't kill revolution. So Fred Hampton is definitely somebody that we should all know about. We should be aware of his work. We should read books about him that have been written about him. There was a movie that included, some of his life recently that came out. But we should read. We should read about him, and we should read about other members of the Black Panther Party who were in community with him and doing similar work to him. On that same night, Mark Clark was another member of the Black Panther Party for Self-Defense who was also assassinated the same night that he was in his home in Chicago. So we need to know about him. Our young people need to know about him, and we need to understand the type of society that we live in before we can create a new one, create a better one. And also, one thing I definitely want us to understand is some of his critiques of monopoly capitalism. I want us to definitely look into that. Because that's also very important, because economics is key. Economics is key, but we got to be very careful about how we navigate this economic system, because there's some good ways to do it, and there's some ways that might not be as helpful and beneficial to us. But definitely study the brother, the late chairman, Fred Hampton. All right. Now, let's get into this. So we want to find the mean, the median, and the mode. Now, normally, when you're doing problems where you got to find the mean, median, and mode, people like those problems because those tend to be among the easiest problems to do in statistics. But that's if you're given a set of data, like a whole list of numbers, right? Now, this information is based on grades in a class, right? But you see the grade ranges. Like, you're not given the specific grades that everybody got. Like, you're not given a list with like 95, 82, then 63, then 45, then 71, then 68. You're not given a list like that. You're given ranges. So those grades are broken down into ranges. From 40 to 49, from 50 to 59, from 60 to 69, from 70 to 79, from 80 to 89, and from 90 to 100. These are grade ranges. Now, because these are grade ranges, we got to do a little more work than we would normally do if we knew the individual grades, right? With the individual grades, we would just add up all the individual grades and then divide by the number of grades, and we'd be done in terms of finding the mean. And with the median, all we would do is put those individual grades in order from smallest to greatest, or we could do greatest to smallest, it don't matter, as long as the numbers are in numerical order, and then we would find the middle value. So if it's an odd number of grades, then it would be the number in the middle. But if it's an even number of grades, there would actually be two middle values. So we would basically take the mean of the two middle values. But again, we can't do that here because we don't know the individual grades. We know the grade ranges, right? And for the mode, we would just find the grade that shows up the most. But again, we don't know the grade that shows up the most because we don't know the individual grades. But the mode is actually kind of just as easy. And I'm gonna show you that in a minute once we get through the problem. We're gonna do mean and median first though. First thing we're gonna do though is we're gonna fill in the value of the frequencies, right? Because we need the frequencies. And frequency is just how often a certain data value shows up, how often it's present, right? That's what frequency is, like how frequently you see it or how frequently it's there. All right, and I got my frequency written down on my little clipboard, you know what I'm saying? You know, you carry a clipboard around, people think you're important, right? So, you know, you might want to try that somewhere, you know, just walk around a building with a clipboard. Watch people like tighten up when you walk by. They're gonna think you like somebody's supervisor, right? So anyway, from 40 to 49, the frequency was 3, all right? Now there's no calculation here. This is just information that I decided to not write up on the board until I started recording, right? So you can see how it gets done. So there were 3 people that had grades between 40 and 49. So imagine this is like a test that, you know, your teacher gave in class, right? 3 people got from a 40 to 49. But again, we don't know what the specific grades were. It could have been 3 people got 40s. It could have been 3 people got 49s. It could have been 3 people got 45s. It could have been 1 person got a 41, 1 person got a 46, 1 person got a 48. We have no way of knowing. All we know is that there were 3 grades that are in this grade range. That's all we know. And that's fine. But we just got to understand what we're dealing with. Now, from 50 to 59, there were 5 people. 5 people that scored between 50 and 59. From 60 to 69, there were 6 people. From 70 to 79, there were 9 people. From 80 to 89, there were 8 people. From 90 to 100, there were 7 people. All right? Now, this column right here, this CF stands for cumulative frequency. Cumulative frequency. You should probably write that down in your notes. Cumulative frequency. That means the total amount of the frequencies added up to the previous ranges. So for example, from 40 to 49, there were 3 people. So the frequency is 3. But here, individually, there were 5 people in the 50 to 59 range. But when we deal with cumulative frequency, we add the previous range to it. So this is 5. This range had 5, but this range had 3. So we add 5 plus 3 to get 8. That's how you get cumulative frequency. And then we keep doing it over and over again. So really, this right here covers this range from 40 to 59, 40 to 59, 40 to 59, which is 8, because 3 plus 5 is 8. And then this right here is going to go from 40 to 69, 40 to 69. So that's going to be 3 plus 5 plus 6, which is the same thing as 8 plus 6, which is 14. Then this one is going to cover 40 to 79, 40 to 79. So you see what happens with cumulative frequency, right? Now, if you're dealing with percentages, if you were given a chart that had percentages in it, it would be kind of easy to figure out. If you know the total amount, you would just go in order. You can still figure it out. You can still convert from a percentage to the individual numerical cumulative frequencies. All right. So we want to go from 40 to 79. We're going to do 14 plus 9. 14 plus 9, I can add 10, get 24, and then subtract 1, right? That's called, I think, rounding and compensating, or some term for that, right? A lot of ways to do mental math addition, right? So that's 23, right? From 40 to 79 is 23 people. So you see how these numbers keep progressing, getting larger? And then from 40 to 89 is 23 plus 8. So that's going to be 31. So 31 so far. And then from 40 to 100 is going to be 31 plus 7, so that's 38. So this is the cumulative frequency. So that means there are a total of 38 people that are accounted for. So 38 people were tested. All right, 38 people took this test. All right, now cumulative frequency is important because we're going to use cumulative frequency to help us find the median. You need the cumulative frequency to help you find the median. Keep that in mind. Cumulative frequency, median. Cumulative frequency, median. We're going to get to that in a minute after we fill in all our information. Now this column right here is midpoint. But over here, I just use the letter M to represent it. Midpoint. Now, why is the midpoint important? The midpoint is going to be part of the formula that we use for the mean. There's a formula we use for the mean that includes the midpoint. Like I said earlier, if we had been given the specific test grades, we could just add up all the specific test grades and then divide by the number of grades and get the mean. But we don't know the specific test grades. So what we do is we kind of estimate a value for the range, and we take the midpoint of the range. We use the midpoint of the range, right? So the midpoint from 40 to 49. Now there's a formula for that you should write down. I'm about to write it on the board, and you should write it down too in your notes. There's a formula to find the midpoint. The formula for the midpoint is going to be the lower plus the upper divided by 2. That's the midpoint formula. The lower, now in the range, the lower value plus the upper value divided by 2. Lower value plus upper value divided by 2. Now again, why do I need the midpoint? I need the midpoint because that's going to be part of the formula that I use to find the mean. That's going to be part of the formula that I use to find the mean. That's why I need the midpoint. All right? Always know why you need something when you're doing stats. Well, really when you're doing any type of math. Know why you're figuring certain things out. Like, why am I figuring this out? Why am I calculating this? Because that's going to help you to understand the process and memorize the process much better if you know why. And also always be able to explain why you did what you did in any math problem in any step, right? Because then you'll understand it better. And also you can help your classmates out, help other people out because you can explain it to them. All right. So we're going to figure out the midpoint for each of these ranges. 1, 2, 3, 4, 5, 6 ranges, right? So first I'm going to do 40 plus 49, lower plus upper, lower plus upper. 40 plus 49 is 89. 89 divided by 2, 44.5. Now you're going to notice a pattern after a minute, right? After a minute, you're going to notice a pattern. And once you notice the pattern, then we're not going to have to do really the calculation, right? So then we're going to do the same thing for this range. 50 to 59, 50 plus 59 is 109. 109 divided by 2 is 54.5, right? So we got 54.5 now. All right, now 60 to 69. Now I noticed the pattern. Notice how it's always going to be if it's in the 40s, it's going to be 44.5. If it's in the 50s, it's going to be 54.5. If it's in the 60s, it's going to be 64.5. And break out your calculator and prove it. You know, prove me wrong if you don't think it's right. But it's going to be 64.5. You notice the pattern. And this one is going to be 74.5. This one is going to be 84.5. This one is going to be, now this one's going to be different because it doesn't go up to 90, it doesn't go up to 99. Pay attention to the details. This goes up to 100. So halfway between 90 and 100 is 95. Or you can say 90 plus 100 is 190, and 190 divided by 2 is 95. So this has a midpoint of 95. Now again, why did I find the midpoint? I find the midpoint because we need the midpoint to use in the formula for the mean, which we're about to find in a minute. All right, now, F times M, F times M. What is that? This is F, this is M. This is F, this is M. So that means we're going to multiply each of these values in the frequency column by their midpoints. Each of these frequency values are going to get multiplied by their midpoints. That's why I got the multiplication sign right here. F times M. All right, so first I'm going to do 3 times 44.5. 3 times 44.5 is going to be 133.5. And I'm going to do the same thing for each of these. Then I'm going to do 5 times 54.5. And that's going to give me 272.5. And then I'm going to do 6 times 64.5, which is 387. And then I'm going to do 9 times 74.5, which is 700.5. Then I'm going to do 8 times 84.5, which is 676. Then I'm going to do 7 times 95, which is 665. Now, another thing I need to do for the formula for mean, which I didn't write yet, but I will, is I need to take the sum of all of these. And this Greek letter right here, sigma, it stands for sigma, right? This represents the sum of all of these numbers. The sum of all these numbers, right? So the sum of f times m. So when you add them up, you get a sum of 2,834.5. 2,834.5, right? That's what you get, okay? Now, let me give you the formula. Let me give you the formula for mean, all right? The formula for mean is, I'm gonna write it over here. So mean is equal to sigma, which is the sum of f times m, divided by sigma of f. Now, I didn't find the sum of the frequencies. Sigma f means the sum of the frequencies. All the frequencies added up. I didn't do that here, but I could do it right now. And keep in mind that the cumulative frequency ends with the total of all of the frequencies anyway. So we know that this must be equal to the sum of the frequencies. So we know it's going to be 38. In case you want to check it, just go ahead and do the math. 3 plus 5 is 8. 8 plus 6 is 14. 14 plus 9 is 23. I'm going to do 23 plus 7 because that's easier than adding 8 for me. 23 plus 7 is 30, and then 30 plus 8 is 38. And I could do that because of the commutative property of addition. The order that you add the numbers up in don't matter. You still get the same answer or the same sum. Remember that. That's why those rules are important. But anyway, the mean is equal to the sum of, see, sigma stands for sum, right? It's a Greek letter sigma, which means the sum of. This means you add everything up. Any of y'all, you ever use Microsoft Excel? You see the sigma formulas, it means the sum of, right? Same thing here. The sum of f times m. That's this number right here. We did f times m already. We add them all up. We get this number right here. So this number is this number right here. So we got 2,834.5. We're about to get the mean real quick. Divided by the sum of the frequencies, which is 38. So therefore the mean is 74.59, which is approximately 75. That's a 5. So 5 and above, give it a shove. That makes that 4 go up and turn into a 5. All right. So the mean of these grades is 75. All right. And we had to do a lot of work, you know, but actually, and this seems longer than what it actually is because I'm going through step by step. I'm trying to be very detailed. So I'm taking a long time, right? Because I'm going through step by step. If I was doing this problem on my own, it wouldn't take me this long. I'd have been done. But because I'm trying to explain how to do it, that makes it seem longer than what it is. So I don't want you to also be, you know, confused about thinking like how long things are. Of course, like when you sit in class and your teacher is explaining how to do a problem, you're going to think it's going to be longer than real time. It's going to be longer than reality, right? Just like when somebody explains anything to you, they go slow. They talk about all the details. They go step by step. Don't think that if it takes somebody 20 minutes to explain a problem, that means that you're going to take 20 minutes when you at your desk sitting down doing it on paper. It's not going to take that long. It only takes that long to explain it because they're actually explaining it. When you're doing it, you're not explaining it. You're just doing it, you know? And you're going to get to the point where you're going to be doing the problem that takes 20 minutes for your teacher to explain it. It's going to end up you might take you 3 minutes to do it once you get the hang of it. All right. So this is the mean, 75. Now the median, let's get to the median. The median, this is how you find the median. You first take the first thing we got to do is this, right? We got to do a couple things to find the median, right? We're going to do sigma f. Yeah, there you go. Sigma of frequencies divided by 2, right? Now that's kind of similar to what we would do if we had individual data values. we would add up all the grades and divide by, we would take the sum, well, no, actually, we would take, and what we do? No, actually, we wouldn't do that at all. We would just find the middle value. We would find the middle value. Or we would do the greatest value minus the smallest value, take that difference and then divide by 2. Or we add the, I forget, we might, because I usually just list out all the numbers and just find the middle value. But there is like another formula you could use. You could do like the greatest value minus the smallest value, or the greatest value plus the smallest value, and then divide that by 2. One of them. But anyway, this is the formula we're going to use right now. Sigma of the frequencies divided by 2. So sigma of the frequencies is still 38, right? So we're going to do 38 divided by 2, which is 19. Now that's not the median. 19 is not the median, right? What we have to do is find, the median is going to be one of these grade ranges. The median is going to be one of these grade ranges. The median is not going to be a specific value. You know why? Because we don't know the specific grade values. So how could the median be a specific grade value if we don't even know the specific grade values? We know the ranges, 40 to 49, 50 to 59. And what we're trying to find out is which one of these grade ranges has the median grade in it. All right. So if we do 38 divided by 2, we get 19, right? You ask yourself, you go to the cumulative frequency column, right? Cumulative frequency column. And you say, okay, well, where is 19 at? All right, where would the 19th value be at in terms of cumulative frequency? So the first 3 are in this range. The first 8 are in these 2 ranges. The first 14 are in these 3 ranges. We're looking for the 19th one, right? The 19th one is got to be in this range, 70 to 79. You know why? Because this range right here, now pay careful attention to this, because this might get a little tricky. This range right here has the grades from 15 up to 23, right? The 15 to 23, like in terms of order, right? The order of the value of the grades, the 15th highest grade up to the 23rd highest grade is in this range right here, 70 to 79. 19 is in between 15 and 23. So what you got to do is, when you do when you're trying to find the median, you take sigma f, right? And then, this is a video, so you can always rewind it, run it back if it doesn't make sense. That's cool, right? You take sigma f, which in this problem is 38. You divide it by 2. That number is 19 in this problem. And then you go to your cumulative frequency column. Cumulative frequency column, not your frequency column, not your midpoint column, not your FM column. It's all about the cumulative frequency column. Cumulative frequency column, then you look for where this number would be. It's not in this range because 19 is bigger than 3. It's not in this range because 19 is bigger than 8. It's not in this range because 19 is bigger than 14. It's in this range because this range goes from 15 to 23. Now, how do I know that this range goes from 15 to 23? Because this range right here stops at 14. What number comes after 14? 15. This range right here stops at 23. So that means that this range covers the grades that are in the position from number 15 to number 23. Now imagine these grades are ranked like they are. They're ranked from lowest to greatest, right? These are the 3 lowest grades. These are the 8 next to lowest grades. These are the 14 next to lowest grades. These are the 23 next to well, it's cumulative frequency, so you get my drift. What I'm trying to say is these grades in this range, right, are increasingly higher, right, than the grades beneath them in 40 to 49, 50 to 59, 60 to 69. So that's what you got to do every time. But this is a part you got to focus in on because there's a lot of details with this, right? How to find the median, Use cumulative frequency, do the formula, sigma f divided by 2, and you got to find this number. You got to say to yourself, where is this number at? Where's this number at in this column? Where is it at, right? It's not in this range because this range goes from 31 to 37. 19 is less than that. It's not in this range because this goes from this goes from 32. This range goes from 32 to 38. So understand also that these numbers right here are the highest value in that particular range. That's what these numbers represent. 38, 31, 23. So you in this range right here because 19 is in between 15 and 23. So really focus in on that and make sure you understand that. Understand where I got the 15 to 23 from. I got 15 to 23 from the fact that this range right here stops at 14. Well, these three ranges stop at 14. The next number at the 14 is 15. This range stops at 23. So that means that this range right here goes from 15 to 23. And then you say, okay, well, 19, the number 19, like I know how to count, so I know where the number 19 is. 19 is in between 15 and 23, right? So that means it's in this range. So this is the median. The median grade can be found in the 70 to 79 range, which is similar to the mean. And the mean is 75. So that's, they're similar. Now, the mode is probably the easiest. The mode is just the frequency that shows up the most. So you go to your frequency column and you look for the biggest number. So I got 3, 5, 6, 9, 8, 7. Here we go. 9 right here. 9 is the biggest number. 9 is aligned with 70 to 79. So the mode is 70 to 79 also. So the mode is from 70 to 79. The median is from 70 to 79. And the mean was 75. All right. So now, this is a frequency distribution table. I know this video was kind of long, but like I said, it was long because I was explaining everything, explaining every single detail. Plus, we talked about Fred Hampton in the beginning. You know what I'm saying? Again, do your research on Fred Hampton. Make sure you know about him. All right. But it shouldn't take you. But when you're doing one of these problems, once you get the hang of it, and you might want to watch this video a couple times, right? But also make sure you take good notes. Make sure you take good notes. Pause the video if you need to. Run it back. Rewind it if you need to. But make sure you know, like, what is frequency? What is cumulative frequency? What is the midpoint? How do you find the midpoint? How do you find the cumulative frequency? What is this for? F times M. This is used to find the mean. Because look at the formula right here. Sigma of F of M. What does sigma mean? Sigma means you add everything up. That's the sum of everything, right? This is called sum notation, or some textbooks call it sum notation, right? So we got that, and then we just plug the numbers in. That's all we do. F times M was these in this column, add everything up. The median is probably the trickiest part, at least for me. For me, the median is the trickiest part. Mean is straightforward, because with the mean, it's straight like, all you gotta do is just, if you know this formula, you good, right? You know what the frequency is. You know how to find the midpoint. Use this formula. Lower plus upper divided by 2. 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 And so on. You're going to know all your midpoints. This says F times M. Multiply. 3 times 133.5. Do this for each row. Do it for each row. Do it for each row. To find the mean, it's straightforward. Then you get to the bottom, you finish. Add them all up. You get this number right here. And you can do the same thing for every problem. Anytime you got a frequency distribution table. Anytime you got a frequency distribution table. As long as you got the frequency and you got the raw numbers and the raw data for the frequency, you can figure out all this other information. You can figure out the cumulative frequency. You can figure out the midpoints if you know the ranges, right? You can figure out F times M. You can figure out all that. So just know your formulas, right? Know how to find the median. Remember, for the median, take the sum of the frequencies and divide that by 2. Whatever number you get, you got to find where that number is in the cumulative frequency. Where is that number at in the cumulative frequency? In this example, our number was 19. We'll call this our magic number. Our number was 19. It could be found in this range from 70 to 79, because this range covers the values that are from the 15th position to the 23rd position. From 15th to the 23rd position. Right? And that's that. And the mode is the easiest in my opinion, because the mode, you just go to the frequency column and you figure out what's got the biggest number. That's it. All right. So I know this video took like about 30 minutes, same time as a Martin episode, you know what I mean? But I hope it was helpful and hope it was detail oriented enough. And with this, you should be able to find the mean, median, and mode in any frequency distribution table. But definitely go get some practice problems and do some problems. Even create your own data. You can create your own data based on sports, based on anything, you know, video games, whatever. But you got to practice, because if you don't practice, none of this is going to matter. Because this is not a spectator sport. You can't just watch me do it. You can watch me do it to learn it, but then you got to like get your hands dirty and like start doing your own problems, or else you won't ever learn it. All right? And then when the tests come around, you're going to be out of luck. So definitely go get some practice problems. Ask your teacher, ask your professor, ask whoever, or if you can't get some problems from another person, go online, do some research, look for worksheets on frequency distribution tables, finding the mean, median, and mode. Do that. All right, so go get some practice. I'll see you on the next video. Peace.